Hello, everybody. Welcome back to another Veloren Reading Club. This is our third one, and today we're going to be talking about the entity component system in Veloren. And so, for anybody who is new to this Veloren Reading Club, our objective is to sort of show a lot more of the insides of how the engine works and give you a little bit of a walkthrough on some of the more core systems. But what we've actually been finding is that in doing a lot of these walkthroughs, people have actually been able to find a lot of systems a lot more accessible to start working with, and we've seen some really great contributions in the last few weeks from some of the earlier reading clubs we've done. So without further ado, I'm going to bring James on, who's going to be the one to lead us through the entity component system today. So let's see here. All right.
Oops.
Okay.
Yeah. I'm James. I'm one of the many developers of Veloren. I've been helping out for a bit over a year now, which is a lot of fun. And I've contributed to a lot of different systems and parts of the code and learned quite a bit. So I'm going to talk about how we use ECS, or an entity component system in Veloren that really helps out a lot of things. A typical video game developed in something like Unity does not use an ECS. Instead, it'll use something where it'll have like update scripts, or if you're used to Godot, it'll have scripts attached to different objects. Actually, I have an example of a really simple game I made a long time ago, or a few years ago, where this is just a really simple terminal platformer that I made, where you can see things moving around. I'm trying to avoid objects. But the idea with this is that everything is updated by an update function. I have something running that's updating all the enemies. This is not the most efficient way of doing this. It works for my tiny little game here. But once you start adding lots and lots of entities doing all kinds of different things, you have all kinds of scripts running at the same time, and it's not super efficient. Then you have to start dealing with how does the engine actually choose which systems to run at different times, not systems, which update functions. And so that can create a lot of backlog, a lot of inefficiencies. That's where ECS comes in. So in Veloren, pretty much everything you see, all the main core systems running on the server are using ECS. We don't use ECS for everything. It's not fit for everything. That's something important to remember. You don't want to throw everything in ECS all the time. But it definitely helps out in lots of ways. So I'll just give you an example of how that works in the code. Let me go over here so you aren't seeing crazy stuff. So I'm just going to go into the common crate. And in here we have we have a components directory, which is where we have all our components. So an ECS works by having entities, which is each, I guess, an entity is just a number, or it's an ID you assign to something. And instead of having an object with data assigned to it, you compose basically I'm going to call it an object, it's not an object, by adding components to it. And each entity can have an arbitrary order and number of components. Standard examples, you see you have something like, I don't know, a horse and a cart in a video game, and you want them both to be able to move. You can try doing some crazy inheritance stuff, but Rust doesn't really do inheritance. Let's use traits, and don't recommend using it that way. It'll just make things worse. But instead, everything's data-oriented. So we compose I call them objects again, they're objects, of the cart and the horse by adding different components. Those components are what hold the data. So the horse might have a position, a velocity, and some kind of movement component. We'll also have other components that could be whatever. And the cart will have those position, velocity, and some kind of movement or physics state components as well. But they're very different. But we can add.
Sorry, I'm just gonna pause you for a second. We're getting a little bit of audio stuff, so I'm fearing that maybe having Discord open at the same time is causing some issues, and so I'm gonna make the executive decision to say that you must leave the Discord channel, and I'll try to pipe the audio through. But if you're watching on Discord right now, go watch us on YouTube. That's where you get the good quality stuff. All right, so James, I'll bring you back here.
Okay. Hopefully the audio is coming through.
Yeah, it seems to be doing better now.
Okay, cool. Yep, this kind of makes sense. So we have these components which we add. This is where we have all of them. You can see we have a bunch of random different things. I'm going to go to one which everyone should probably be familiar with, called health. So you can see a lot going on here. We have different structs and all kinds of different things going on. But the main component that's actually being added to entities in our case is this one here, pubstruct health. And it has certain data that's assigned to it, and we can give it to different things. And now when we want to update all these entities, instead of having an update function for all the horses and all the carts, instead we have what we call systems, which iterate through entities, but only by querying for specific components. So it can make sure that something has a health component. It will only look at it if it has that health component and certain other components. So in this case, we have health. It's isolated in this module. It has certain data assigned to it. And then it also has lots of functions and methods assigned to it that make it easier to work with. Health in particular is a little interesting because of how we use floats versus integers to deal with it. Outside of this module, it's an integer, but inside this module, we use it as a float, or vice versa. I can't remember. But oh yeah, we use floats outside so we can multiply by float values, but everything inside is an integer to keep it in whole units. So now let's look at the system. So here's where we have all our systems in the common folder. We have other systems in like server and other places, depending on the code. Let's look at a simpler system. Let's look at the R one. This is one that I implemented. It's not too difficult. So in order to use a system in the ECS framework we use, which is called specs, you have to implement the system and do all this kind of boilerplate. It's not that bad. You get used to it. But some people, that's one of the reasons they don't like specs, is because there's quite a bit of boilerplate compared to some other entity component systems libraries out there. So in this case, what we're doing is this run function we really want to pay attention to. This is what runs every tick and updates everything that's going on. So what we're doing here is we are querying for read data, auras, and buffs. Those are different components. Read data is actually not a component. You may have noticed something sneaky we did up here. We made a struct with all these different, these are all components or resources. I should explain what resources are too. Resources are basically globally accessible things in the ECS that you can pull out. But they are in a separate space. They don't have an entity assigned to them necessarily, kind of above that. So things like time and like the server bus for sending events, those aren't components that we're adding to a specific entity. Those are resources we're adding to. But instead of having to write all of those out in one long tuple here, we put it all into a struct just to make it easier. We started converting over to that a few months ago, just so it's easier to read what's happening. So now we have all these components that we pulled in. Now we can start doing our code to actually run through what happens. So an aura is it's an area around some entity that emits some kind of buff normally. So in our case, like campfires, they emit a healing buff if you're around there. So here we can start iterating, doing whatever. You can see that we iterate through all the buffs that are on entities and check if, or that are from an aura, and make sure whether that they were recently added or not. So we don't continually add the same buff over and over each tick, because we want to save on resources. Then we edit. Here is where we actually do the more important stuff for this particular system. We iterate through each entity, each position, and the aura component. There's actually plural auras in this case, because you could have multiple. And now let me go ahead and open this up. This is where we have our aura component, which you don't have to have a system name the same thing. We just do because we have one way to make it work. I'll show you a case very soon where we don't do that. Yeah, feel free to ask questions. Type in the chat. I'll try to get to them. Let's see. Okay, basically what's happening is we have I believe it's a hash map of, no, it does not look to we check to see if things are expired or not. This is what this is. It's just a vector. And we're going through all the auras that are available. We subtract time, which is what's going on here, so that they can run out if they're timed. This right here is fancy spatial structure that we're using to be a little more efficient about checking distance between objects, so that we only look at things that are in the same area. We cache that, and that's Embrace's magic. That was not there when I originally did this, and it became an expensive system really quick because it was checking every single other entity that was loaded by the server. It was not good. So now we check if the target is within a certain distance, which is under our radius, and now we start doing our magic we check for group, we check that it actually is the right, here's all the group checking, and if it is, then we just simply activate the aura, and we throw in all this that it needs. That's the idea of how a system works, the basic idea. Sometimes it can get very, very complicated. Let's look at the physics system, for instance. This guy is a monster. You can see we have 2,000 lines of code in this one file, this one system. Now, not all that is directly, we have a bunch of helper functions out here, but it can be pretty scary. Actually, this one is rightfully scary. It should be scary. We don't want people just messing with this because it's pretty important. Physics eats up the most of our CPU time on the server, and we want to reduce that obviously as much as possible. So here you can see we haven't even gotten to the run function. That's all the way down here at line 1200, almost 1300. And here is where we start pulling in everything that we need. So physics data is actually a component, if I'm not mistaken. Or no, it's not. I believe we, nope, it's physics data. It's probably a struct we created up here. Well, physics data is right there. Yeah. So basically, we're making things easier for ourselves by creating extra structs. That's a really good pattern to use in Rust, where you create structs to throw into your functions if things are getting too complicated. But yeah, this can get pretty complicated. And you can see, look, the actual run function itself is tiny, but it's because we're doing all these things in these helper functions. Now, this tends to be more efficient than trying to run those update functions I was talking about. And you don't have to worry about any kind of inheritance problems that you would have in object-oriented. Yeah, it is doing a lot of things, as Esther was saying. This is probably one of the most complex systems. It's also, yeah, the other one that's also really crazy is the the agent system. This is what does all the NPC AI. And because they need to know everything that's going on, we pull in all these different resources, and actually that's not even all of them. We pull in a ridiculous amount of resources and components that we can do AI properly or better. It's very difficult to make things do things you want them to do. Yeah, here's our read data that we're pulling in. These are all different components. It basically has to have access to everything. Specs actually has a limit on how many components you can pull in a tuple. I believe it's 17. So having the struct actually allows us to get around that, because otherwise when we get to our run function, this tuple right here, it wouldn't allow us to have it larger than 17 values in it. So this allows us to get around that. I could talk about how the agent system works because I've done a lot with it, but it's not really worth going into unless people really want to hear about that. Okay, which cases have you found ECS to hinder rather than help, and how do you integrate ECS with your larger code base? Yeah, so ECS isn't something you want to add on as an afterthought. Unity with their dot system has kind of made it seem like that, but if you notice, dots was mentioned like several years ago, and they're not really using it anymore. They're kind of, it's on the back burner. I'm not even sure it's going to get integrated properly, and it's because you can't just add an ECS to an already existing game. You have to build everything around your ECS. That's kind of your core data structure system. So it's not that we integrated ECS into our larger code base. We started with ECS as a way of how we're going to handle our data. And how we found it to hinder versus help. I don't have a lot of game dev experience out of just like random projects and working on Veloren, but I only see it helping, to be completely honest. In the Python code I've done before, I've ended up with some very nasty inheritance stuff going on, and it kind of makes a huge mess and makes things inefficient as well. Trying to iterate through all of those. Here we can iterate only through what we need to and limit it just to that, which can help a whole lot. I don't know if I answered your question. I hope it did. But you can look at Unity with their dots numbers of like how many agents they're able to get going at the same time. It made things ridiculously more efficient, at least in their RTS simulations. But like I said, I don't think they're actually going to implement that in the main engine with Unity, but Unity has a lot of other problems that I don't want to get into. So now I talked a little bit about the basics. I tried not to go into the boilerplate of how specs works in particular. Let's go ahead and talk about how we could add to this. Let's talk about adding like a component and a system. Typically with systems, you don't necessarily want a system just to work with one component. It's a balancing act between what's more efficient, between having a system for everything or putting different code together in one system. I don't know all the details, but basically you want to kind of group things together that belong together to make them a little faster. We use just a plain ECS. It doesn't have archetypes or anything like that. There are some fancy tricks that people like to use. In Rust in particular, people go a little crazy about ECSs. The reality is it's rarely ever your bottleneck. Normally it's your own code with what you're doing that's your bottleneck. So I'm going to go to one other system really quick. This is our stats system. We do not have a stats component. Here we pull in things like health, poise, energy, your combo, and we use that. And we update all those in this system because those are all kind of similar. So we just kind of group it together. So this is kind of where we do that. Adding more systems, like I said, is typically not warranted unless there's a good reason to. With our system, it kind of made sense because it was kind of separate than everything else going on. Same with we have a buff system that's separate because it doesn't iterate through the same way that other code would. Whereas in this case, we kind of want to loop through everything, and then that has these components and update them based on what's happening. Here it's all about, where is it? Here we go. We apply effects after leveling skills. We update energies and poises depending on what your character state is. Regular stuff like that. So let's say we wanted to add a component. If anyone has a suggestion for a component, we can try doing that. What I think I'm going to go with, though, is because it's wintertime and it's getting cold, let's talk about temperature. We do have temperature in the world, but we don't integrate that at all into gameplay besides just world-gen. So I'm going to add a component for, I don't know, internal temperature basically of each entity. I'm not sure the best way to word that. If you'll have suggestions, I'd love to hear them. I'm going to go ahead and copy over a current component. I'm going to copy the health component and start with that. Actually, because I don't want to deal with all the floats and stuff. That's fine. I just wanted to be simple just for the purpose of demonstration. And we're actually going to leave it as temperature because that way we could use this component with other things that are not agents walking around. So like we could use it for a character to say they're cold or hot, or we could use it for something completely different. So I'm going to leave it just as a generic temperature component. So now I just copied the code over, but let's go ahead and change all that. And here, basically everywhere that's health, we're going to change it to our component. Oops. And I am not going through this as carefully as I normally would. I'm just changing all this and oops, probably making Sam roll over in his grave. Oops. So I just went through and changed everywhere where it says health to temperature or to temp. which is not necessarily the best idea. Oops. Okay. Let's just look at health change because I know we have that in here. Okay, I'm going to do a bad thing. I'm just going to get rid of all the tests because writing tests is a good idea. You should do it, but we're not doing that today. And more tests. I don't need. And kill, we're going to get rid of this. Okay. It's a little more manageable at this point. Yeah, okay, this is much better. Cool. So now we have a temperature component, but it's not actually added to the ECS yet. Right now it's just a random module. Rust isn't even aware of it. We haven't added it to our mod file. But let's just make sure everything makes sense. So, oh yeah, you want me to make this bigger. No. Oh, I disabled, sorry, I disabled keyboard shortcuts for my terminal emulator because I was using all my Vim and Tmux shortcuts and it was bothering me. They're getting in the way. So here we go. So let's talk about temperature. We need the temperature component to have, doing another bad thing, I'm just getting rid of comments because it's probably not accurate. But we have a current value for what the temperature is, the base max, maximum. That doesn't really necessarily make sense for temperature. So we do need a current value for sure. Let's talk about base max doesn't really make sense. I don't know. Some kind of limit for comfort, I guess. And same thing for a minimum. Let's see. Is dead should not be part of this because that's dealt with by health. I'm not going to worry about that for now because we aren't worrying about damage in this case. That should be dealt with by health. Yeah, tolerance range works great, but I don't think we want a, what's the right word? I should know this. I think it's a unilateral tolerance. We want bilateral tolerance. We want to be able to control up and down, I guess, if that makes sense. Because otherwise we have to define the middle. Yeah, no, definitely. But that's why I was thinking having a max and min that's different could be valuable. So I'll just leave it as that for now. I don't think we even need a temp change. This has to do with, we do that with health change, or we keep the last change so that we can do things like targeting for different stuff. I don't think we need that here. So let's just start with that. How much temp it currently has, that doesn't make any sense. There we go. Okay. So we have a current value. We have a comfort max and a comfort min. So we have some kind of tolerance. Outside of that, damage occurs, let's say. You could simplify this by having a mean value and some kind of standard deviation or something, but well, I wouldn't simplify it really, but that's another idea. So let's go here. That's looking at the implementations where we're having all our methods. Current. This is good. Returns the current value. Yes, most of the work is just copying existing code and deleting most. The other part that really matters is following error codes. Rust is great in that you'll hear people talk about zero cost abstractions all the time. They're really compile time abstractions that do cost you in terms of compile time, but not at runtime, which is what's really important. So basically, because of the static typing system, it can do a lot of checks that other languages wouldn't be able to do based on the types of your data. Yeah, and if you have any questions or anything, feel free to ask. I'll do my best to answer those. Let's add a function for, I don't know, is comfortable. Though my naming here is not necessarily great. And this will just check that that current is less than, no, we'll do less than. And that's just inside the range, basically. And if it's not, then we can do whatever we want. That just gives us a way to check that. And yeah, if you wanted merchants to only sell hot chocolate once it's below a certain temperature, would you use the system? No, you would not. So this is actually not a system, this is a component. You would do that in probably do that in the agent system, because that's what is checking, that's what's actually doing the action. But you could pull the temperature, yeah, actually the temperature out of the entity's current chunk. I was thinking that we also have it in column data, I think, which is what I was planning on doing in just a little bit. Fraction. I think we're just going to deal with a Boolean value right now. We don't really care about. No, okay, this matters. Not even sure we need this function. I'm going to leave it for now. Let's go here. Okay, normally you would have some base temperature, whatever, from whatever. I'm not going to do that. We're going to do this a really janky way that just that we have an example. Let's say we haven't decided what our range is for temperatures because we're using, I should check what our range is actually for health. I think it's to 256. Maximum value is that, but we don't want to use that. Using integers, I don't know. Let's just say it's 256. No, that's our, yeah, that works, their max. I don't particularly like that, but that works, that's fine. So 256, we're gonna have, my brain is dead. Sorry, I've been working 13-hour shifts at a manufacturing facility the past 2 weeks and my brain is a little dead. So I'm gonna use a calculator. There we go. Oops. So we're gonna say that the current temperature is 128. And we're gonna actually, to go below, we don't want to use 0 because we're using unsigned integers. So actually our range should probably start at some value. Yeah, it honestly should be floats for everything. I would just go between 0 and 1 just to make it easy, which I'm going to go ahead and change this to. So current, we're just going to make it a float. Same thing here. That way we can go negative if we need to, which is helpful for temperature because honestly we should use Kelvin, but our minds don't work that way. We're just used to different systems. So, and I don't think anyone plans on going full Tolkien and inventing a temperature system along with languages for everything, but that'd be neat. So we're going to say our current temp is 0.5. And we're going to say that the maximum is 1.0 and let comfort min equal 0.0. That works for us. And we're just going to go here. Okay. So now our new function works. We don't really care about body at all. So we're going to do this. I'm just going to do new. Let's make sure I'm going to get rid of this function, even though theoretically should be able to do things like that. Let's just make it super, super simple. We're not even going to do all these checks that we should do to make sure things are safe. Well, actually, it's not an integer anymore. We're going to get rid of temp change. We're just going to, we're just going to add values to it. I don't recommend doing this for anything like this, but it's a good way just to get something working. And as anyone who's done any coding will tell you, incremental work is important. Yeah, 100 degrees below in the temperature, which cheese melts. Sounds perfect. Okay, we don't actually need these casts anymore. Oops. Oh, no. Yeah, and the reason we have these getter functions is because those were not public values in here. You can't just pull them out. The struct is public, which means you can use it elsewhere, but the actual data values are not. That's why we use the pub keyword here. Let's see. Change by, we're going to get rid of all of this. Sorry, Sam. And we're just going to say it F32, and we're just going to go self dot. There we go. Super simple, super gross, but it works. And we don't care about that. Okay, this is important down here. Here's where we're actually implementing. This is the boiler code we need for specs to make this a component. We're using a certain kind of storage called direct flag storage. You don't need to know the details of it. Basically, this is what you need to add this in order for it to actually be implemented as a component. So let's see, do we have everything we need? Back. What do you mean by that? I don't know if that means anything specific. I'm just gonna keep it going. Let's see. Update maximum, we're gonna get rid of this for now because we're just trying to get a simple version working. Current, we have another cast that we do not need because it is already afloat. Oh, deleting code. Oh. Yeah. We don't need any of these consts anymore. Yep, like Zester said, basically when you implement a new thing in Veloren, it's pretty much copy, paste, delete half the code. Now this is much simpler. It's not as resistant to problems as the system was. Temperature does not go infinitely in both directions. You can't go below 0 Kelvin, and yeah. But in our case, we're pretending it does. So there are problems with the system for sure. But it's enough to get us going, just to get an idea. So now we have that code there. What does Veloren's codebase do with it? It doesn't actually know. This is where we use, I probably don't need all these things, but yeah. Basically, so we have that component, but the code doesn't know about it. Like if I do cargo check, I don't think it will even check it. Oh, I should have done this beforehand. This may be a bad idea. I may just want to do cargo run instead. Yikes. Oof. Okay. Cargo check is utility with cargo to verify your code is good. People use an LSP, language server protocol instead for things like Rust Analyzer. I don't, because my computer doesn't work very well with it. I could probably compile it faster because I already compiled just before this. But yeah, so basically everything that was updated, it's having to check again. Luckily, it doesn't have to redo everything because I didn't do cargo clean. Yeah, so if there are any questions, I'll happily answer them right now because I can't. I don't want to edit code while this is going on. I can show you what's going on though. So let's go ahead and go back here. Actually, let's just do. So back in our common module, common is code that's shared between the server and the client in most cases. Actually, in all cases, that's why it's there. So let's go back to our component. module here, and we have a mod file. This is where we export basically all those modules that happen. You can see we have all these different components, buff, compass, whatever, dialog, and we're exporting those, so those are available elsewhere. All the config attributes you see for WASM, that's for WebAssembly. That's for our plugin system, just still very early days, but that's to allow things to go into plugins. Now this is finished. You can see it didn't see anything. I'm pretty sure, or it should have seen that there were a bunch of unused imports into that file. So in order to do that, we're going to go back to that same folder or file I was just looking at, that mod file, and we're just going to add. Basically, everywhere there's health, I'm just going to add temperature. I think did I call the module temperature, or did I call it? I did call it temperature. Let's make that. We're just going to call it temp. Clarity. Temp. Okay. And actually, let's do it this way. Okay. And now we also need to add it here. I think. Why is that separate? I don't know why health is down here in its own thing. Maybe there's probably a reason for that, but typically we would just add it in here, so I'm going to do that. Okay, so now Rust should be aware of it, or Cargo should be aware of it. So I'm going to go ahead and run cargo check again. Why is it jumping all the way back? I probably shouldn't have added the, yeah, so now we get all kinds of errors. This is the great thing about Rust. Some people really hate this, but it's honestly the best thing. So you can see here, I just threw in comfort max. I didn't tell it to get it from self. So that's an error on my part. It's really nice having that at compile time and not later, because normally that's what would happen. Where was I? Oops. And now it's telling me all these unused imports, which is very true because I didn't use any of these anymore. I don't need that. I don't need this. I don't use that. I think. Is that it? Let's just run the project again really quick. And I believe that's it. Yeah, sorry, I don't have the most powerful computer, so it's taking its time right now, especially with trying to stream at the same time. Okay. So that should be good there. So now we should have this component, but it's not added to anything. So when you have components, you have to add them to entities, basically, in order for them to be used at all. So we do that mostly in a few different places. But on the server, let's say when we spawn an entity, I'm going to go there. I believe this is the right file. Yeah, right here. So you can see here, we're using a structure, I believe, that we defined. That might be part of specs. Yeah, that is part of specs, the entity builder. This is what we use to add entities to the world. The world is the collection of basically all the entities with all their components and resources, everything that's accessible. Typically, when you have a game with different levels and different things, you might need to use different worlds for those. Because we don't have different levels like that, we just have one world. One specs world. So here, I'm just going to add. put it down here just so it's next to the other stats. I'll go right after boys. Yeah, that works. So with, and now we're going to go comp temp new. I believe that should be good. So basically what we're doing there is we're adding it. Or sorry, we're just adding that component onto an entity. In this case, we added it to our create NPC function, which is what's used when it creates new characters in the world. Yeah, so here you can see we get a nice warning from Rust telling us that you have a value that's unused, and you should just like leave it there basically. So we should change that to a let underscore. In a language like Erlang or something, every function always returns something. So like this wouldn't be something that pops up, but in Rust it is. So yeah, the other thing working on Veloren has really done is made me appreciate a lot of things that Rust chooses to do compared to other languages. It makes me a little sad. I was recently trying to learn Julia a little more, and I keep missing features from Rust. Yes, we definitely should clean up the functions. They're a little massive at this point. Okay. So now we added these per 10. Oops. Wait. I'm in the right file, right? Oh, no, it says add name. Okay, so now we have. Yeah, same. So now we have a component, but it's not being used anywhere. So how do we do that? To make it super, super simple, we're going to go to, instead of creating a new system, which we could do, it would require copying a lot of boilerplate, which is a good exercise. Because we're just that one component and it's kind of a stat, we're going to go to that stat system that I showed you earlier. So now we have a different crate for systems. Stats. And we're going to do, well, we get the, no, actually, I want to pull the world temperature data. So that's in a resource, I believe, it's the terrain. Zestro will probably correct me in a minute, but let's go ahead and create a new system just for the exercise of it. So like before, I'm going to do the great thing of copy and pasting. We'll grab stats. Yeah, so typically you don't want to create a new system for everything, but we're going to in this case because we might use it for more, especially for temperature, something that could be used in different areas. Yeah, it's in the drain map. That's what I thought. Okay. So that's why I didn't particularly want to put in stats, because I didn't want to pull in an extra resource just for one stat if I didn't need to. It wouldn't have been the worst thing in the world. But the other thing to keep in mind is by default, each system will run once per tick, which can be a lot for some things that don't need it. So, okay, train grid, cool. That is a, I believe that's a, yeah, it's a resource, cool. Okay. Yep. Yeah, that is ripgrep. That's using a plugin called Skim. Skim is basically FZF, I don't know how to pronounce that, except for it's using ripgrep instead. And Skim has a Vim plugin, which there's an fzf.vim plugin. I'm using the skim.vim, basically the exact same thing, but I like Rust, so I'm using ripgrep. Okay, so now for our read data for this new system, let me get rid of those. We need all the entities. We will probably want to look at time eventually, but for now, I'm not. I'm going to do the inefficient thing. We probably will need position to get the check position. UIDs. Eventually, we would care about bodies. Right now, we don't, because I set everything to have the same temperature range. Character state. Inventory, we probably do want to check, actually. We want to check if they're wearing warm clothes. There is no heat stat. That would add that. I would add that with this on this branch. So I'm just going to comment that out right now. We also need, let's call it train. Okay. And okay, I'm going to have to find where train here it is. I believe it's in the ECS somewhere. Oh, yeah, that's right. I've used this before for things, but world create. I just don't know if we use it. Oh, no, it is. Here we go. It is just called train grid. So here, this is on the server. You notice things might look different. It's not a system. It's pulling it out from the ECS directly and reading that resource. That's another way to do things. Sorry, I'm going hoarse. Okay. So we have our terrain pulled in, but we need to define where that's coming from. Oops. That's in common, right? Oh, handle bonk, yes. We have great naming systems, don't we? That's the real reason to start coding with Veloren, because it's a great group of people who do great stuff with the code. Okay, so we do not care about this stuff, really. Actually, we probably should pull in health to mutably affect health if it's outside of the range. So we're going to get rid of that. Poise, energy, we don't care about that. No. So we just want to get the train positions. I think it should be good enough. That's the name of the system. We use that for, I believe we use that name when we do our metrics. So we are mutably affecting health. I don't know, though. Maybe that should belong in the stat system, but we'll leave it here for now. Actually, yeah, that probably should. But for demonstration purposes, I'll leave it here. So look at our system data. We have just the read data, which is that struct up here. Here we could individually list them all. I'm going to go ahead and leave it as a struct, though, in case we add more. And then anything that's mutable, it's easiest to put it here, which is just this write storage. That's the struct that Zex uses for anything that writes to versus a read storage for components. And then a read up here is for a, this is what we use for a resource, like the terrain. So now in our actual function, we are not emitting any server events, which we probably should, but that's not what we're going to worry about. We're going to update temperatures. Here we can iterate through basically all the components we have pulled in. So we are interested in, wait, where did it? Okay. So we're going to go here, entity, we don't care about that, or that, more deletion. Position. Okay. We have entities, care about that, and positions. Okay. This is all we're iterating through in the system right now. And I'm going to go ahead and just delete everything in here. Okay, so now we have this. I'm actually going to go ahead and delete even more. So you can have multiple joins in the same system, where you iterate multiple times for different components. In this case, I'm not trying to do that. So we're just going for a simple case. Okay. So now we have just our for loop iterating over the entities that have a health component and a position. That's what we forgot, temperature. Oops. I did put that in up here, didn't I? No, I did not. See, I'm already making mistakes. I'll call that temps. And now we need to pull in that struct. So that's in comp here. Cool. And now we should be good to go. Okay. So what do we want to do with this? We want to take the entity with the temperature. So now we have, this is looking at each individual entity with the health, position, and temperature. First thing we need to do is we need to get the temperature from the world data, from that chunk where it is. Let's go back to, am I still in, oops. Handle bunk. Okay. We have our terrain. I might need to, it's been a while since I've done this. Let me go ahead and go back to the agent system really quick. I just want to make sure I am pulling in the resource correctly. Yeah, I believe I'm good. Okay. Let's see, what does that question say? Is train grid only loaded chunks? That's a question for Zester. I don't believe so. So now we have terrain. Okay, it is only loaded chunks. That makes more sense. This might need to be chunk position instead of world position, but has it as, in this case, this is going to be an entity position, so now this should work. Okay. So we're just going to map that position. Wait, no. Why was it? Yeah, position is a float, so we're mapping it onto the block instead, which we just floor it and cast it to an assigned integer. And now we're going to go here. So we're going to use the same structure. If let sum block. If let statements are great. They let you unwrap. Except for. So now we're going to look at where this is bonkable function is. We don't really care about that because that's returning the individual block, which we don't really care about. We care about the temperature for either the chunk or the our place. So this is already in the wrong. This is already the wrong module for our case because this does not have temperature value or temperature data. So we're going to go back to that terrain grid, which is a vol. I think it's a. Oops. So here, find space. This is used. Okay, it's a thing of terrain chunks, right? Yeah, it has terrain chunks. So let's look at the terrain chunk. Okay. Yep, let's look at what Zester is saying because he knows what he's talking about. Okay, terrain husky and then terrain.get key to get the chunk. Yeah. Okay. I just want to make sure I know where to. Okay, this does have temperature. Cool. So I believe that's between 0 and 1. I don't know. But I reread things every time I go through here. So we're going to train. Yeah, it is a little annoying, the way that we have to access chunks for stuff, but it works. So we get our chunk position. Yeah. So the chunks position, as Zester is saying in the corner, chunks are 32 by 32 by 16, I believe, in terms of block size. So we have to convert between chunks to blocks. Because our position that we've already calculated here is in blocks, not in chunks. So we get our chunk position, which is from the terrain. We throw in our key, the actual world position, in blocks. And now I believe that's not an option. I believe that is a value, but it might be an option. I'll find out in a second. And now we use get key, and we throw in the chunk position. Okay, that's probably an option. So this is, yeah, that's probably an option. So we're going to have two if-let statements within each other, or we could map onto each other. But we'll pretend it's not, and we'll let cargo tell us, or rest format, or whatever, cargo check tell us that it's not in a second. So now we have, this is not a block, this is a chunk. And, oh, it's just straight value? Okay. So these are not public fields again. So we need to be able to get that temp, I believe. There is a function, because I think I added it. Or no, I don't think I added it, but I think I used it when I was looking. Mm-hmm. Yeah, there we go. There it is. Okay. So chunk.temp. That's what we're looking for. Let temp equal, there we go. And that is, I believe that's between 0 and 1. Infallible, because I just don't care about truncation. Okay, cool. So we're going to, we need to map this somehow on our values of 0 to 1. We're just going to say, I don't know. I'm making up random nonsense right now. So if anyone has better ideas for how to do this, I'd love to hear them. We're just going to go here. But oh, temp needs to be mutable. Let's do this. So I just moved temperature down into the actual system data tuple because we're using it as mutable because we need to change it, obviously, as we're changing the temperature. So I'm just saying if the temperature is over, actually that's what Zester says, he probably has a better idea. Oh, it's -1 to 1. Okay, cool. Sounds good. In that case, we're just going to do this. Temperature plus, we're going to go, oh, I shouldn't use temp. This is chunk temp. Temp plus equals 0.1. Now this is going to happen every single tick. This is going to be a mess really, really quick. But just to give an idea of how this works. And there are more idiomatic ways of doing this, I'm sure. I'm just trying to knock it out fast. We're going to say if it's under -0.5, temp plus equals, or minus equals 1. And then we're we're going to have temperature slowly move to whatever the chunk temperature is. Think that makes sense? But we need to map the values. So chunk temp is between -1 and 1. We want to map that to 0 to 1. Yeah, so we have a value. So let's just go 0.5 times t plus 1.0. So that should map it to 0 to 1. And normalized chunk temp. And now we're just going to, if normalized chunk temp is greater than temp, we're going to temp plus equals 0.0. And this is gross what I'm doing right now with flow, so I should be skipping. I shouldn't be running this every single tick, but just for the idea, this is what's going on. Let's see what Zester is saying. Oh, he's saying 0.5. I think it's going to happen too fast because it's going to run every tick. And so it's going to be a little wild. Oh, did I my normalized function? Yeah, that's right. Thanks for catching that. Yeah, Rust cannot catch logic bugs for you. For that, you need a Zester. Okay. So now we have a basic system which should add temperature a lot faster if we're if it's warm, and cool it off if it's really cold. And then at the same time, it should bring it to your normalized temperature, whatever it is in your chunk. If it's still temperate. What we're also going to do now is we want to affect health if it's outside of the comfortable zone. So in this case, we're going to look at, we're still in the same for loop. We don't need to iterate a second time. We could easily have a separate loop for health, but I don't recommend that. Actually, no, we couldn't because we already got our temperature here. But we did that inside this if let statement, so we need to do it in here. And if temp is, oh, you know what? These shouldn't be just plus add. It's I already forgot the exact code that we just wrote a second ago. Okay. Okay. We have a function for this. We can't just add values. I mean, I could implement add in the operation functions or from standard library, but I'm not going to. I'm going to use this change by function that we added. Oops. Oops, I hope some of this is making sense. I'm not just rambling to myself. Pretty good at rambling to myself, unfortunately. Oops. Okay, that should be good. And this is chunk or temp.current. Okay. Thanks. Let's see. Temp.current is greater than temp.comfort max. Else if temp.current is less than comfort min. Okay, so in here we're going to mess with our health. And in order to make sure I use the right functions, I have to use the health change function. We're just going to go to our stats system. Oh, we do have a stats component still. I thought we got rid of that. I'm curious what's actually in it. What do we even? Oh, that's where we keep those things. Okay. Cool. So I'm wondering where it's the name primarily that we use. What is this? Yeah, the coding is not quick and easy and fast. Oh, my words per minute. Okay, it's looking a lot faster than it actually is because I'm using completion and I'm using Vim shortcuts to move around faster. I'm not that fast of a typer. I think I'm only around I think I'm around 60 words per minute. I may be generous. I think I'm slower than that, but I have an aunt who does stenography who's around 180 words per minute, so I'm not that fast. Where was I going? I was going to the stats system, so I can look at how we do health changes here. No, do we not update health here? We have command literally to oh, this is the kill command, I'm guessing. No, it's not. Okay. Okay. So here we go. Oh, you're one of the pecking or the pecking typers. My dad does that. You can actually get impressive times by not using touch typing. But this by and cause we probably should fill in. I believe is an environmental thing. So we have amount HP minus health.current. I think this was used in the, this is in the command file. I have this feeling this is in the, oops. No, it's not. Okay, I have a feeling, we have a health command? I did not know that. Okay, learn new things every day. I thought that was part of the kill command. But that, I believe that directly erases your entity without messing with health. Health change, I don't know. might need to add health change source. Yeah, that's what I'm planning on doing. But I think we have a environmental or natural one already in there. I don't know what the amount should be. Where is HP defined in this? Where does HP come from? Oh, it's the argument. Okay, so that's fine. What health to put it up? Is that cause? I believe that's cause. Okay, or maybe that's by. We'll fix it in a second. Okay. It's in death on touching snow. Yeah, it's going to be pretty dramatic, I imagine. Let's change this to. I honestly have no idea for values, so we're just going to do something crazy, and I think just do -5, and if we die, we'll find out. For cause, yeah, this can be none. I'm just going to leave it as none for now. And time, I guess we need to put in the time. So in this case, we need to pull in another resource, the time resource, and that is fine. We're just going to go back up here. Everywhere I use terrain, this should be read data. And the reason it's read data is because we just read it. We never write to it. That's what allows us to do that. Time. I believe it is just time. I don't believe I need to dereference it in this case. Okay. And we're just going to copy that and put it here. And if I do cargo check again, it won't do anything because I haven't added it. Rust needs us to add it. Oh, is there not a mod file in here? There's a lib folder. Here we go. So mod temp. And we need to, this is also important. We need to, this is part of specs. You have to add systems. So you have to dispatch them, basically. We're going to do, I'll just copy this down here. Okay. And I believe that should work. Yeah, because it doesn't care about physics, or it doesn't depend on the order. That's what you see some of these other things. I believe this is where we're defining this has to run after before certain systems. We don't care about the order here. So I'm just going to leave it as that. And I believe at this point, I should be good to go cargo check and it'll yell at us, which is the great part about Rust. Yeah, so if there are any other questions, yep, you can see we already forgot something. Here, I put a semicolon. This should be a comma. And, oops, I'm missing a whole. That's right there. I don't know why. Oh, it's because the semicolon messed it up. So basically, actually, I do plan on merging something like this eventually, or hopefully getting something like this merged. But I don't know if in this, it'll probably need some change. So here I put mute temps. This should probably be mute temp, I'm guessing. Let's see what I did. Yeah, always look at the top error first, typically, because often that can affect the errors further down. Let's see, where are we? Nope. See, I forgot to add temps right here. As part of the system data, point that out. Okay. And actually, these we can go ahead and change it. It wants a float value. Okay, it does need to be reference, it looks like. Oops, did I go too far? Okay, this should be chunk.meta.temp because it's not actually the chunk meta, or terrain chunk meta, which is another struct that has the temperature data. So let's see. Okay. Okay, it's because I put in the wrong variable name. Pretty simple. Let's go ahead and get rid of some of these unused. We don't need that. We just need position. There we go. And we don't need that either. Okay. We're not dealing with server events, which it should, but we're not. Yeah, what really should happen is either this just be a server-side system. There's no reason to run it on the, at least in my mind, there's no reason to run it on the client as well. But yeah. Oh, yeah, so variables, all that happened, what I meant by that is very simply, I said W for world position when my variable name is POS, just position. But it's actually a good idea to change the name of my variable because right now it's actually shadowing the position component, which we just pulled out of the entity component system. And it's not really a good idea to, in this, shadowing can be confusing, especially for other people to read your code afterwards. It's typically not the greatest idea unless you're building something, you keep on adding to it, but you don't want to mutably affect it. You don't want to mutate it. You just want to change the values. So you're basically having a builder pattern which keeps on pumping out new values. That's kind of like a functional. Instead of having a bunch of like maps after each other, you keep on defining the same variable name as a modified version of itself, but it's not actually mutated. It's just added to or changed in some way. I forget what else happened down here. I should read back in the health component Sam's nice comments about damage is negative. It doesn't give, let's see. I just wanted to know how much, get an idea for how much health is, but it doesn't look like that's going to happen. So we'll just change this to 5.0. And if we instantly die, we'll instantly die. Oh, that's right. We can change that to chunk.meta. Yeah, sorry if I'm moving fast. It's Vim makes code editing look more like magic than it really is, which I highly recommend everyone use Vim, but that's just my personal opinion, or I guess in this case, NeoVim. But, and it does look like I'm going to need to dereference this. That's because it's a wrapped type, and we just want the value from inside. I only did it for one. Chunk.meta is a private field, but there's a function. So let's go back here to meta, and down here, dereference this guy. Okay, we still have a bunch of unused imports. That's fine. Combat, UID, hash that, and back. Okay, so now we see some nasty looking things. So here I need to, position is it's a vec3, but it's wrapped. So I just need to unwrap it. And you can see here's the type, the struct position. All that it has inside of it is a vec3. So I'm just going to dereference it. I think that should work. Let's go ahead and get rid of some of these other unused things so we don't keep on popping up. Okay. And I already forgot what else I was going to do. Temp is a private field. So let's go back to meta and change this. It's a function. And what's going on right here? We'll just run that. So does it need a default value in order to work? We put other stuff in the ECS. Oh, I forgot to dereference that. Let's go. Read expect, is that what we're missing? Okay. I forget all these types every single time. And I always look them up by looking at other systems. Yeah, so if they're using read alone, yeah. If what I'm doing looks like magic to you, don't worry. I'm not a professional coder at all. I didn't even study. I need to bring this into scope. I didn't even study coding in college. I've literally taken 2 coding classes in my life. Everything else is just for fun. I don't know if Zester is referring to the name of read expect. I think he is. That it needs, or yeah, because read needs a default implementation. Okay, cool. Now we're back to more regular errors. Okay. Can't you just map values, or am I making things up in my head? I haven't touched Rust in like a week. Yeah, we should just be able to. Okay. Because I know we do that. What other system did I do that? Actually, it's not in a system. I did it in the audio code. Okay, I am pulling a dumb right here. I can't, the life of me cannot remember what I should be doing. Where I just want to map this position, but it's the, shouldn't this dereference it? Or no, I have to do this. Here we go. It's a tuple. I should get rid of that one error. Yep, and now we're just left with the chunk temp. Where it's an F32. I mean, I'm kind of slow this morning too. Well, I guess this is my morning, but yeah, that's what I'm gonna have to do. Oops. No, I don't know my way around Julia at all, actually. It's kind of bad. In college, I was supposed to use MATLAB for all my assignments, but I decided wouldn't always have MATLAB, so use Python for everything. And then towards the end of my senior year, I was like, Julia is the new hotness. I should learn that instead of Python. But by that point, I was already liking Rust a lot. So every time I try to use Julia, like it hurts inside. It is theoretically a functional language, but it's not, I don't know, it's not quirky enough to interest me. And the ways that it's different than Python bother me. Okay, cool. So now theoretically, this should all work. Let's go ahead and get rid of these. And what's the other one? Entity. So we have to iterate through entities because of, well, we need to check each entity. That's kind of how ECS system works. Each entity is like an object in the world or something in the world. But we don't actually care what it is. So Rust uses an underscore when you don't actually care about a value. You can put that in a function name or when it's not used. And that tells the compiler that we don't actually care what this value is. It just needs to be there for whatever reason. That should get rid of all our warnings. What I should probably do is also give us a way to check what the world temperature is. I don't think that's in the debug info right now. Or did, actually, no, I remember. Let me, do I have another terminal open? Let's see. Okay, the reason I'm doing this is before I compile. I just want to make sure that I want to check if we already have the temperature in the debug info, or if I should add it right now so we can check what the world temperature is. And I would turn the sound off, but it's too late for that. Or I can't access settings. That's one of the oldest issues actually with Veloren that everyone brings up, is that the settings in the start menu isn't accessible. That's because we use two different UI toolkits. We're using Iced for the main menu. We're using Conrad inside the game. The character select also uses Iced. I'm really looking forward to Christoph's work on the econ sim. Supposedly it's supposed to be a whole lot faster. It's not that long right now, the simulation that runs every time the server starts, but it'll be cool to see that get faster. I also want to plug in some more to the agent code and mess with that. If my audio goes choppy right now, it's because my computer's working very hard. Time biome. Oh, I have terrain persistence on, sorry. Okay, temperature is not there. Let's go ahead and add that really quick. And that's somewhere in Voxygen, so I'm just cheating because I saw words that were there. So okay. Yep, that was from the glider course. Actually, I was recently thinking about how to procedurally determine good gliding courses and add them, but it'd be a fun project. It would just take a little bit of time. Actually, you know what? We're going to go old school for this way. I should add it there, but we're just going to put it, we're just going to print line. Chunk temp and oops. No, let's not do that. Okay, oops, that's what I meant to do. Okay, that will print the current temperature, so we'll know pretty soon if things are working. Actually, the create NPC function runs also for when characters are added, right? That's not a different function. Just want to verify before I go ahead and compile it, because otherwise it won't affect us and will only affect NPCs. Let me go ahead and check. Initialize character. This runs create NPC is separate from character initialization. Okay, it doesn't use that. So let's see, where does it do it? Yeah, it makes sense because you don't want to add agent, but it is a little, maybe initialize character data. Oops. Is it here? Yeah, I believe it's here. I think this is the right function. How advanced can AI go? I mean, theoretically, the start's of the limit. Unfortunately, that requires someone to program it. And number one thing with AI coding is it's very easy to add one specific behavior that messes up everything else. And if you're only looking for the specific behavior you added, you won't notice that anything is wrong, which requires a lot of testing. And unfortunately, most people don't realize that and start adding things. And I get annoyed because I worked pretty hard. I should have made it the system use types to the. I should go back through the behavior tree and make it use types such that there aren't invariants that you can break, so that it requires you to follow certain patterns, which will make it more foolproof. But I didn't do that when I initially changed it to behavior tree to give it a little more freedom. But since then, I've seen some stuff happen, which makes me a little sad. It works right now, mostly, but AI is a very tricky thing to do right. Entity components, and we are doing temp. Yeah. Okay. This one. Okay. Now ladder provides some initial info and start loading in the ladder. Okay. So I think this should be fine. I'm loading from database, hopefully. Okay, well, so it's initialize character data. What was the other function you were saying? Update character. Let me. Update character data. Oops. Okay. Will this overwrite components I've already added? Update characters only. So if I went ahead and added the component in the initialized data, it should be fine, right? Like, obviously that's wrong for long-term stuff, but just to test that, that should work, I think. Just want to initialize character, cool, perfect. That's what we did. So now we will run it and see what happens. This might take a minute. So if anyone has questions, I'd love to answer those. See, am I missing anything? No. So what I was going to do was add the temperature to the debug info like we have for biome and some other stuff. And then I saw all the Conrad UI stuff and thought, I don't want to deal with that, and just used a print line, which is great for debugging, not so great for actually using in the game. Yeah, no, I don't need a persist temperature. And so right now, with the way that I've written the system and the component, everything has the same temperature range value that it's comfortable in. And right now, it's only characters that have temperature values, which is fine for testing. Obviously, we could use that temperature in different areas. And something we should have done as well, if we wanted to use the temperature for other stuff, we would want to not necessarily require a health component. So in order to do that, we use a special keyword from specs called maybe, which allows us to bring in iterate through entities which have components, but optionally. So then it'll bring it in as an option instead of as a value. And then if it has that, you can use it, or if not, you can choose to deal with that option however you want. Yeah, so great question that Zester is posing, like what kind of data is available in the ECS to make use of. So we put pretty much all our anything that goes between the server and anything that's important on the server is pretty much in the ECS. What that means is some of your graphics data, like animation and that's not in the ECS. The ECS is not aware of that at all. You can't access that data within systems. But from all these systems that run on the server that are important for how the game actually works, it can access your character state, your physics state, your position, your velocity, your alignment, which, yeah, if anyone has creative ideas of how to deal with alignment in video games, I'd love to hear them because I'm out of good ideas there, but that's a long thing to talk about. It can talk about, we have an agent component which has some different data, which has to do with agents in the world. A lot of different things. Pretty much, if you need it to do some kind of core or something which doesn't depend on the front end, it's probably in the ECS. So going back to that original example I showed you of the, I still have it open. No, I don't. But going back to that original kind of, what does agent encompass? A lot. Let me show you. Okay. The reason I'm using bat there instead of vim is it's read only, and I won't accidentally start editing things while it's trying to compile, and I don't want to mess with stuff. So this is the okay. Okay. This is the actual agent component. It has an RTSim controller, so that's agents can be controlled by a real-time simulation. We have a patrol origin. That's kind of where if an entity is just wandering, it'll always stay within a certain area. It won't just wander to the ends of the world. It'll return to that place, or not necessarily return to that, but it'll wander only around that. They use it as its distance from that point as a heuristic to determine its bearing. It can have a target. That's what we use target for both an owner, someone to follow, and also something to attack. The chaser is a struct which holds all the pathfinding data, basically. That will return it returns a bearing from your pathing. So you don't really need to know what's going on behind the scenes. You just need to get your bearing out of that. The behavior was something that was added. It's a bit flag, or uses bit flags to say whether certain agents have different behaviors or are allowed to do different things. We don't use it very much. The idea was to take heavy use of that, but we haven't really touched it since adding it. Psyche holds, I believe it only holds, let's see, oops, I guess it's not in this. Psyche have its own, yeah, I guess Psyche is defined somewhere else. I believe it just holds aggro values. I think Zestromif changed it recently, so that may not be right. The inbox, I added that one. That's for basically all kinds of notifications. What I mean by notification is like when you talk to an entity or talk to I can't speak. When you talk to an agent, to an NPC, when you hit the E button when you're walking around town, it receives something in this inbox. That's where that goes, and then it processes it from there. The action state is used to have timers for different actions. That's really important for combat, for like swinging. Yes, Psyche along with like behavior, they're both great ideas, but we haven't really used them to their potential. Yeah, so what you're talking about there on Comfy is alignment. Right now we just have an enemy alignment. The problem is we want alignment to be dynamic to some degree, so that you're alignment could change. So how to deal with that properly is a very, very complicated thing. Yeah, timer is no longer used in combat. We use action state. Action state, as you can see right below here, has a timer within it, and it's a much more flexible system. Zester added that. I'm not sure what we still use timer for. It might just be for trading, but we should be using the action state there as well. Bearing is the direction that you're facing. Oh, it's only a vec2. I thought it was a vec3. Huh. That's weird. Okay. Then sounds heard is for the sound system. There's a sound system where there are server events that are not connected with what the front end produces as SFX. Well, it is indirectly. Certain actions happen on the server, which cause your client to emit sound effects. Those same actions cause the server to emit these sound systems. Okay, that makes sense. But shouldn't that entail up and down movement as well for bearing? No, we use jump. That's right. Okay, we have that as separate. I forgot. But so the sounds heard, that's where those all come from. But they're not one-on-one lined up with all the sounds you hear in the game. That's also another reason for that is we don't want to spam that system. We don't need to hear every single sound effect that you hear in the game because an NPC can work with a lot less data theoretically if we code it properly. Awareness is how aware an NPC is of hearing those sounds. Oh, that's okay. That's right. The bearing is specifically just for the wandering. Now I remember that. The position PID controller is only used for vertical movement right now. I'd like to move that into chaser so it's abstracted away so you don't even know what's going on because we define chaser within the agent system. And yeah, I'd like to abstract that away, but a PID controller is a proportional integration derivative controller where it not only takes your actual value of your input, but it takes the derivative of that and the integral of it to determine what your next value should be. It's used control theory, all PID controllers. But we use that to try to smooth out the airship movement as it flies along. Otherwise, they bounce around a bunch. The problem with PID controllers is you have to manually tune them. I did some work on 3D pathfinding for flying entities. And I went ahead and I used a PID controller for a duck. And I was like, oh, this works great. And then I spawned an eagle and realized it completely did not work for the eagle. And then I decided I don't want to go through and manually tweak all these constants for all these PID controllers for every single flying species. So I removed what I had already and just said this is enough for now, just the new pathing system. But let's see how that compilation is going. Oops. It is getting there. Yeah. Let's see. Yeah, so the alignment question is a very good one. That's up here. Yeah, you can see the different sound kinds. These are the different things that entities are aware of. We don't actually use some of those yet. Movement, for instance. But yeah, I probably should have just compiled the server instead. But actually, no, I put the system in common. I should have put it in the server system. But it should be unless it runs. I'm not super familiar with how common actually works and how it divides up the code. But let's see. Oh, here's Psyche. It has a few different distances. Yeah, I should have put the this system I added just in the. Here we go. Just on the server. The agent system is just on the server. Here's our behavior, which we only use for trading, I believe, right now, and can talking and trading. And right now, our trading code is a little messy. It needs to be cleaned up, but yeah, you can see we hard code all of this hostility, which hard coding is typically not good. Well, no, hard coding is basically never a good idea. Yeah, Psyche now does hearing as well as sight. It checks those. Okay. Because we added that listen. Oops. Okay, so this is great. We got an error. What's going on? It's telling us that we never added the component like we should have. Which is actually, I get this error almost every time I add a component. But if you try reading this error, it looks kind of scary. Try to fetch resource mass storage in the world doesn't exist. So what do I do when I get to this point? I just start copying help or some other component. And I believe I need to go into here. Oops. Yep. Yep, time to register the component. This is what I forget to do every single time I add a component. And I've added a few components, not a lot, but I've added a few. I probably shouldn't be putting this right next to poise, but this doesn't matter at all. I'm going to go ahead and put it just so my fake OCD is happy. This is what's important. We have to actually register. Well, this is the tracker, not quite. We have to register the component with the world. Yeah, so as Zester and Sam are both saying, a lot of stuff I just said there is not actually essential because it doesn't need to be in the Sentinel file. It needs to be in, which one is it? It's around here somewhere. I believe it's state. You know what? I'm just going to go back to my this one. And that's not important. It's not important. Just want to make sure I have it everywhere I need it. A lot of these, it doesn't matter. So like entity manipulation deals with server, what's it called? Server not messages, server events that are sent from clients or whatever, or that belong on the server. And so it just deals with manipulating those entities. But that's not going to register anything. It's just going to deal with existing stuff. Yeah, this is what I think I need to go here to the state. I think, but I may be making that up. I think we're good. I think we're actually good. Let's see. Oops. Okay, we're not going to do that. Okay, nope, it's in common. Thanks, Sam. There we go. Yeah. And I do this every single time I forget. I wonder how fast these will. They'll probably take longer than just running the whole thing at this point. I was on an old branch, or a branch that had branched off the master a while ago. So right before this, I updated my Git. Okay, I'm actually going to use the bathroom, so I'll be gone for a quick second, but it's compiling here. I'm still alive, but I'm just going to, yeah, I'm going to mute myself really quick.
So yeah, once I pull myself on stream, I think it's just me here. So hello, welcome to the intermission. I hope you're all enjoying the entity component system talks. I've been in and out a little bit, so I've been not watching too much of what's going on. But I think it's kind of cool seeing how all systems go together. And I also want to say, definitely, like whenever I'm coding in Rust, I've got like VS Code open with Rust Analyzer and stuff like that, and my 16 threads in my CPU are doing all the work to make sure that I don't that when I make mistakes, like I can fix them right away. But like I'm very impressed by how James is doing with all of the manual code and stuff like that. Yeah, so I think I don't know. We got some cool stuff coming up in the next few weeks for anybody interested. We have our Christmas party happening on the 25th. So that's gonna be a Saturday. We normally do them at like 1800 GMT, and so yeah, on the 25th, I think. So it's gonna be sort of like a release party. I think we have a lot of people working on Christmas themed stuff right now, and so if you wanna check that out, if you wanna come hang out on Christmas Day, then you can definitely do that. I've seen some of the work that people are doing uh in the server for like assets, and then also just spawning stuff around the world, and then I guess like this temperature system as well can maybe play a part in it. Oh, okay, cool. Now we can look at we got Veloren server compiling over here. Classic. Uh wait, pulling it forward and prolonging the date. Well, I guess like we have like maybe it's like a longer Christmas um sort of, yeah, like event, maybe like week long, like holiday event or something like that. But then we have the one day where we're going to do more stuff. All right, so I'm gonna take. Wait, how do I unsolo myself? All right.
Well, it's still compiling, so nothing exciting over here.
Yeah, I was just talking about some of the upcoming release stuff and like the Christmas party. I've just muted you while I'm talking. But also, oh yeah, so we have the release party. We have all the holiday stuff coming up. There's something else I wanted to say, and I don't remember what it was. Oh, I also wanted to say I would love to see some type of system where when you want to go and compile Rust, you can like send it off to a server to compile, and then it will send you back a binary. I think that would be like a pretty cool kind of thing. And there are some projects that might, like I looked into a little bit. There's something that might do that, but it'd be cool if we had like a Veloren compile server for all the core devs to be able to use. Anyways, I'll hand it back over to you, James. Wait, I don't think I can unmute you. Yourself.
Oops. Can you hear me? Okay, cool. Have you seen IntelliJ's new IDE fleet?
I have not.
Because that's one of the things they're talking about with it. If I read the news correctly, that that it has an integrated system to allow you to work on a server somewhere else and work collaboratively, basically using SSH. But that it's built into your IDE. And that way you can compile your code and run all your code anywhere, basically, using their new IDE.
I'll have to check that out. I know with VS Code you can like remote into a server and then mount that as your file system and like use it for everything, and then like you can VS Code live share your like just basically a client for that. And so that's pretty cool. But yeah, I haven't checked out what IntelliJ has going on, so this is kind of nifty.
Okay. So what I didn't think about with this is that it's going to, for every single entity, it's going to type in. So let's go ahead and do this. So we are, oh, I have the, where am I? Back. I do not want this one. Okay. So I have to be careful. I might actually kill myself on accident. So right now the temperature is completely fine. So we're going up to where there's snow. Yeah, sorry, I have the resolution really low right now on this. So now I should start taking. No, I said below. Oh, what did I say? I am not taking damage. So something is not quite right. Let's go ahead and spawn in another NPC to see if it affects them. just want a flatter place, or else they're going to go. Oops. Okay. I did take off. Yeah. It does not seem to be taking damage. Oops. And I'm taking, okay. So something's not right. Let's go ahead and check what's happening. Oops, where am I? Oh, this one. So we know the system's running because we have it printing data. So we said if the chunk temp is less than 0.5, and we were saying it seemed less than that. This value may be too low. Okay. Let's go ahead and see if these are ever being triggered. And I would throw in more print lines, but it's going to print for everything. So there's a player component. I could pull in the player component just to test on myself. Yeah, serve to create is 30 TPS. That is great. Yeah, serve to create, so it'd be 0.3 per second. That's really fast, which is another reason why. Actually, on my hunger, that still should work. When I added hunger as a POC, that did the exact same thing. Yeah, this temp change by working correctly, I'm not sure. It could also be the health change. I don't know. I know you're in the chat. I don't know if this is a value that makes any sense for this amount. I just threw in 5. Yeah, I could remove that, but let's check that temp change is working correctly. Change by, I believe that should work fine. Just adds the value. That looks right? Yeah. So a 5 value makes sense there. Let's just go ahead and actually we'll add this. Oh, did I? Oh, okay. I feel silly. That is very true. No, it's not. That is why this isn't working. It's not actually changing the temperature. There we go. Gotta love one line or one. Yeah, Russ previously said you're returning a value which doesn't need to be returned, and I ignored it and said, oh, this means I just need to get rid of the warnings instead of actually fixing the problem. CVE, I should know what that stands for. It's a vulnerability of some kind. I will look it up while it's compiling. don't know if it's any of those. CVE, common vulnerabilities and exposures.
And for reference, in chat, someone was mentioning a CVE that Java had that just dropped today. Pretty big, nice and large 0 day. We love to see it, but Java is not Rust, thank goodness. Or rather, Rust is not Java. There we go.
Yeah. Okay, and I should have just made the world size small, honestly. That's something that I'd like to do at some point, or like someone else at some point, is create a few different profiles for test worlds that are quicker to load. Or even a cargo command which would automatically log you in and pick the first character. That would be nice. Or generate one if it doesn't exist. Yep. And because this computer only has 2 cores or 4 virtual cores, but it's not the fastest.
Yeah. Rust likes cores.
Yep.
Yeah, I think on the topic of tooling, it'd be very cool to see what types of tools you could build either into Airship or something that allows you to, as you mentioned, just load in with a character, load into maybe a smaller world, whatever.
Oh, it honestly wouldn't be that hard. It's just
it's just we haven't done it.
Getting around to actually doing it.
Yeah.
Okay. Let's go back here. Oops, that's not what I'm gonna do. No. Did I set it for 0.75 or? Oh, that was quick. I think it works.
Hey, you got it.
Okay, the funny thing is the health amount was so much that it's going to keep on killing me over and over. There we go. Cool, so that works. So if you wanted to extend the system, we would want to add, okay, that's something I need to fix with agent behavior. Or that would be really simple. If someone wants something to do, taste into agent behavior, make humanoid entities roll when they catch on fire. It's about 2 lines of code, maybe 3. And it's not hard to do at all. I'd be very happy to help someone with that on Discord.
But I think it's very fun to see how you can do very little and then accomplish these very large things, or you can add a lot of not really functionality, but you can add what agents can do. You can make them feel like they're more real just with a few lines of code. So it's really cool how the entity component system sort of works with everything. Yeah.
So okay, this works great. As Uncomfy is saying, the damage is perfect. No need to change anything whatsoever. I could expect that it works in deserts as well, but I think we get the idea. That's how you just add a system. But since I mentioned it, how do you now that you have a system, what do you do to? What's an example of fixing something? What I just talked about. I'm just going to show you where that would be. Just an example. So agent. We just check if you're on fire, which I believe is part of, that's a buff. So we already read the buffs state, and we already do Oh yeah, that would be smarter. Have the temperature system give buffs or debuffs instead of just affecting health. Let's go ahead and do that, actually. That's a great example of how showing how systems interact with each other. If I go into common, we have a system for, well, I'm going to go to the components for buffs. So we have different kinds of buffs. This would be a, I don't even know. Cold. I should probably add new, yeah. Yep. So what Sam was saying is the better way to do this, where instead of just directly affecting health, which if you notice there's no UI, nothing going on telling you what's happening, to instead add something that debuffs for temperature. So let's say, I don't know, my really creative naming system, too hot and too cold. Yeah, burning and frozen already exist, but the if you're burning, it'll start emitting the particles for fire, and I don't think we want that in this case. Otherwise, you'd walk into a desert and spontaneously combust, which would be funny, but I don't think that's what we're going for here. Yeah, and frozen slows movement. It doesn't deal damage. And in this case, we want to deal damage as well. Okay, initial display, yeah, that's fine. We're gonna do it that way. So it's not actually gonna deal damage when you're in the cold. It's just going to give you the frozen debuff. Temp. So now we need to add we need to pull more into the system, which, as an example, what system to add? Let's go with, I think health looks at, or stats looks at buffs, right? But it doesn't not have pulling buffs. Oh, it's a server event, that's why. Where do we spawn? Okay. So we're going to pull in the server bus, which is here. We're going to throw it into read data, which you might think is weird, which it is kind of weird that we're actually going to emit events to a read-only value, but that's just magic happening underneath the hood. Okay, the buff system. Cool. So we're also going to go here, and because I'm lazy, I'm literally going to copy one line. I think we need to bring in time as well, though, in order to emit those systems. Actually, we already pulled the time. We might need to pull in DT, which is delta time between ticks. Actually, I'm positive we do. Oh, shouldn't need time? Okay, we'll find out. I'm just being safe, I guess. Okay. Oh wait, I don't need that. Why am I doing this? Those should not be inside that loop. Let's see. Yeah, I literally copy everything nowadays, and so whenever I work on Veloren, it feels like. So instead of directly affecting health down here, we're just going to comment all this out. And here we go. Buff kind. This is if it's too hot, so we want burning. Now, the nice thing is the buff system will check if that buff is already active, so it won't continually just spam adding buffs, I believe. Actually, no, it's still going to spam server events, which is annoying. But I could do my really hacky methods of getting rid of it, but. Yeah. Okay, buff system handled it fine. Okay, we're just going to leave it for now, just because it's an example. But burning. Let's go ahead and go over here and look up when we add. There should be more places with burning. There we go. Just look at the effects that it has. Actually, we want damage fraction. Well, okay. Data is the 1.0 the strength. Okay. I believe this is strength, right, Sam? I should just look at it, but yeah, it is. Okay. So let's go ahead and change that to something like that, a little less. And then if you were curious why there's an empty vec right here, that's because we allow extra effects, if I'm not mistaken, to happen on top. No, that's not what that is. I'm thinking of attacks. That's different. And here we go. We're going to change this to frozen. Okay. So now we need to import, or I guess it's not called import in Rust, but we need to bring in and I think I pulled in a bunch of other stuff, like, or did I? No, I didn't. Okay, buff change, buff data, buff kind, buff source. Is there anything else I missed? Change kind, data. Okay, and then I also need to pull in, I don't need DT, right? Okay, and I think I may have missed something, but we're just going to leave it at that right now. Yeah, in terms of lighting and all the front effects, we're not really going into that right now, but at least not in this read through. Maybe someone will do a rendering one. We have a lot of cool rendering magic going on. Oops, did I get, oh, duration. That's easy enough. Oh, but I need to pull in server event and then a bus, which I promptly forgot what I just read. Oh, be multiplied by DT. Yeah, definitely probably should, to get rid of some of the tick variable. Server bin, cool. Buff already adjusted by dt. Wait, so what would be multiplied by dt? The duration. Or no, that's the duration. That shouldn't affect that. And the strength you said already deals with it. So I'm not sure. Just make sure that it does not work, which is cool. Vent bus, there we go. Oh, temperature changes. Yeah. But I'm not even dealing. Oh, no, I see what you mean now. You're talking about the actual changes up here, which let's go ahead and add 0 or 2. But have these be multiplied by dt would be the smart move to do. We're not going to do that yet. Actually, we're going to do it. It's the smart thing to do, like I just said. Luckily, Sam is smart, even when I'm not. So, is that in here? Yeah. And we'll go back here. And you can see these values are really wild. I have no clue what those will actually end up being. This would be a great time to use something like inline tweak, which is a great Rust tool to edit constants in your code. But I don't want to compile that in right now. So that should work. Oh, no. So now we actually use the entity, which I got rid of. And we call this 2 different things. So we're going to leave it as server emitter. What else did I miss? Oh, that's I already unwrapped it, so I don't need to do it here. Oops. Oh, am I muted? Let's see. Oh, did Forest drop out? You're back.
You're good. You're good.
Okay, cool. And we're back to watching it compile. Fun times. Let me just make sure I don't read anything. Oh, raise the values. Yeah, because DT is small. Yeah, but as we saw before, those values were ridiculously high. So I think we might be okay. I added an extra 0 in there. Hype for Elden Ring. I'm a weird person in that I don't actually play video games much. Pretty much all my knowledge about video games has come from researching different video games for stuff for Veloren.
Nice. Here for the systems, not for the game.
I mean, it's fun. I don't dislike video games, but
Well, yeah, but I think it is quite interesting that when you are working on a game, you can it's very possible to break it down into like a lot more of a systems type of project than necessarily like a lot about design or a lot about like the end product type of thing. So yeah, a lot you can do.
So the other thing is what's his name? I don't watch a lot of anime, but one of the bigger guys in anime, he's on record as saying like anime was a mistake.
Oh yeah.
And the reason he was saying that is because basically everyone started just trying to emulate other anime in their anime. And he was like,
yeah.
now there's no creativity. So I think there is quite a bit of value in like looking at it as, instead of just trying to like from a gamer perspective, more of just like a, I guess, programmer perspective. I'm not really I guess I program, so that makes me a programmer, but I'm not a professional coder by any means. So there might be some value to that. What drew me to Veloren, I was wanting to contribute to a Rust project to get better at Rust, but I also didn't want to break anything, especially something that was used like actually in the larger ecosystem, which is funny. I now have with Rodeo, which is an audio library, but that's because of Veloren. And I didn't want to break anything, basically. So I wanted to find a project that I felt I could contribute to without hurting anything, where I could still learn a lot. So Veloren seemed like a perfect place. I actually, before I started writing any code, I lurked for a few months on Discord. The funny thing is, I only joined Discord a few months before that for a school project.
So all the stars aligned, basically.
Yeah, and the first thing I did was actually a shader bug, which I had not worked with shaders before at all, but it was an NVIDIA specific bug with shiny water.
I think I remember that.
And I was like, I can just read through this code until the first thing I did was I read all the erosion code. I used to be really into geology. And yeah, I think those values were too low. I used to be really into geology and glaciers, and glaciology in particular. And so I read all the erosion code, and it was like, this is super cool. And then I tried to fix that other bug, the shader bug, which I did. Well, I didn't actually fix it. I was just, because I was helping debug and I had an NVIDIA machine, I was able to help get it fixed.
I see. Yeah, that's pretty cool, though.
I think I decreased the value too much. Let's go ahead and check out a desert. Are there any deserts? This is a desert up here. Wind den. That's funny. Every time this type it.
I was doing a demo the other day, and I didn't know that we had this command to teleport to sites. And so
I don't know why it's not working though.
We just tried that one in the area. And so I would just fly all the way across the map.
No, it is not liking me.
Quotes now, is what Zester says. Maybe you can tap complete it?
There we go. Okay, now it's very hot. So, but it's not adding anything. Oh, this is cool. One of the new desert entrances. I haven't actually seen this one in the world. Yeah.
That is very hot there. Holy moly.
Oh, and if someone was commenting on it being weird that there's no ambient occlusion or anything, that's because I have all the graphic settings like turned down, so it can run at the same time as streaming. This is not normally how the game looks. Okay, so I decreased those values far too much. Yeah, in terms of people using Rust, it hasn't gotten huge industry use yet. Hopefully we'll be getting more. I firmly think like it should replace C++ in industry. It has every reason to, and none of the reasons like not to. But if you've ever worked for a large corporation, you'll know that changing anything takes a long time, especially when you have legacy code lying around. And people who are used to working with one system normally don't want to work with the new system. So it's hard to get that movement going.
Yeah, and I think one thing that I've heard from my friends as like a valid point is that like Rust is not certified as a compiler yet, and so for security critical purposes, like there is work like from the Rust Belt team and from Barra Systems, I believe, in like sealed Rust, and that'd be very cool to see.
The other thing, I don't know about other countries, in the US at least, all computer science programs don't really teach you more than one language. They might teach you Python and C++, but they won't teach you anything else. At least all of the ones where I have friends who are, which is kind of sad. Like, I enjoy trying to learn different languages, even though like I'm not going to use them probably in my job. But and so I think that also might be a problem. All the new talent doesn't know new programming languages unless they go out of their way to learn it.
Yeah, I think a lot of people, when they go and try to, like, if you start a side project or something, that's where a lot of people gain the incentive to try like new languages. And I think that once you try Rust and you come from a place where you realize how much Rust is giving you, then that's when you can like really appreciate it and try to like take it to where you work, and then or like find like a job with it or whatever. And I think for universities, like I've talked a lot with some of the Rust core team at like different meetings and stuff about how when it comes to education of Rust, it's like, how important is it to learn like C and C++ and like all memory management from like the lowest unsafe places instead of approaching it from like a Rust perspective? And I haven't like tried going out and teaching people like systems programming through Rust instead of, or like rather memory management through Rust instead of like C or anything like that. But I definitely imagine that it's not like you don't need to go somewhere and like be like learn through all like these dangerous methods as much as people think.
Java and C++ definitely hold the, like, that's what is probably the most used languages out there right now in terms of industry.
Yeah. Zester mentioned that Rust's fundamental techniques of composing safe APIs from unsafe ones was recently proven sound. That's pretty cool.
When I first started learning Rust, I thought that the memory safe would be like the best feature. But honestly, as I've used it more, it's the type system that I've come to love more. And the error handling, where it's just done in a way which I find really easy to use and saves me a lot of time down the road. In Python, like I can throw something together, but I end up with all kinds of different runtime problems that I wouldn't have thought about. Okay, there we go. I have a buff applying, which is now making me slow and shiver.
That is cool.
Yeah, handling it through buffs is a much better way. And you can see it also makes me jump lower because I'm cold. Yeah, the gliders are great. It's a lot of fun. I was recently thinking about skiing, which would be really cool to add some kind of ski or sledding. I think Zester was mentioning something.
Yeah.
But it's because of wintertime. But
exactly.
You would have to take some kind of gradient of the terrain because, according to physics, it's all boxes. So let's go ahead and jump over. That looks like a desert over there. Okay, yeah, that might still be too high, but.
Ooh, ice sliding. Nice.
Yeah, it's still applying the frozen buff, so I think the rate at which I was applying it was too high. Or is it actually because it's temperature? Oh, I'm gonna die. Pay attention. Let's see what temperature it is. Oh no, I think I should be getting the burning buff pretty soon. That's hot. So I think I'm getting the burning buff. Does the burning not deal damage?
Oh,
that was me
goodbye.
hitting the ground.
Oh, okay. I was gonna say a lot of fire damage.
No, now I'm not getting. What temperature is it? It's hot, but I'm not getting the. That's weird. At least the frozen part worked.
Yeah.
But that's how you can see, like, the systems, the way we have it set up, where we have client and server, and we use events sent between them, makes it pretty easy to add random things happening in different places. I was really hoping I would catch on fire here.
Yeah, I think from like the perspective of adding just behavior in the game, like it was brought up in chat earlier that like the idea that when you're in a desert, like you could like start sweating or something, so maybe you have like some particles coming off, and so adding like these small systems as like a very non-complex thing, or rather you don't have to like really embed them super deeply into some system that could like mess up other things later, really gives it like give you the idea that it's like, oh, I think the character should be doing this in this location. I can implement that, and then it's like this one other little thing that Veloren has. So yeah, it's very cool to see.
Yeah. Yeah, I hope some of this was helpful if somebody got destroyed by
Yeah, absolutely. I think definitely like the walkthrough on how to. I think one of the most important things that we see from these code reading clubs is that we're all using hacky ways to put stuff together. We're copying files, we're duplicating stuff, we're making use of stuff that's already there, and the results that we get are like not impossible to create. And especially with the entity component system, you really see that interacting with the data in game.
There we go.
Oh,
I'm on fire.
nice.
The funny thing is, okay, this is actually very cheesable. Oh no, the damage isn't high enough. Okay, I'm on fire, but the damage isn't great. I was thinking that I could just continually roll and cheese out of it, but I'm not sure that would work based on how fast I'm applying it. The other thing we need to add is you can to catch other things on fire by running into them when you're on fire.
Yeah.
It would be pretty fun. But
yeah.
All right, there you can see.
I think we'll probably end it off here for today. It was great seeing the entity component system. I like Sam's comment. You think stuff is hacky? Just wait till I do one. So yeah, definitely.
Yeah, that's a complete lie. The initial implementation might be hacky, but Sam has learned an awful lot, and it's pretty crazy.
Yeah, it's definitely impressive how people are able to get started on the project and really get integrated with creating good content. So yeah, so thank you so much, James, for giving this overview. I think there was definitely a ton of well, I mean, anybody can go through this and sort of see how to do a lot of this themselves. And it would be really cool to see what people come up with and add small systems for in the next few weeks to come, I think. So yeah, I think that's it. Maybe we can have you back in the future to talk about something else. That'd be pretty cool.
Yeah.
All right. Yeah, we'll see everybody later. Yeah. Or you got something else?
Oh, I was going to say that Zester was saying they're burning now. It's because everything has the same heat resistance at the moment in my implementations, so they call on fire too.
Yeah.
The hyenas that we're chasing.
Oh, okay. Yeah. All right. Well, thank you so much, and we will be back in 2 weeks with another Veloren Reading Club.